All right, let's get started. Okay, so it's called Last Survivors. And let's start in the description. Substitute two equal letters by the next letter of the alphabet. Okay, so AA should be substituted with B. BB substituted with C. Okay, oh, and it's circular, so ZZ just goes to the, okay. The equal letters do not have to be adjacent. Okay. Repeat this operation until there are no possible substitutions left. Let's look at an example. So ZZ, so it would be like these two would be replaced with an A, and then AA would be replaced with a B, and then BB is replaced with C, and then CZ is the return value. Okay. So, wonder how we would do this efficiently. The order of the letters and the result is not important. Okay, so that's sort of a rule here. So order of result letters is not important. The array, or I guess the alphabet, the next letter, I guess rule is circular. And what I mean there is that it's just the example of two Z's being present in a word. So maybe like Z, A, Z. That just produces an A. So the two Z's are excised and an A is returned. And then we would want to, just to complete that, it would just be a single letter being returned for that situation. Okay, so we need to, it seems this feels recursive. But maybe it doesn't have to be. It could just be something like maybe while it contains duplicate characters. I guess a question here though is, do we have to worry about case? So I guess that would just can be like an example here. So case matter, question mark. And then we can maybe have like something like A, C or something. And then would we expect this to be BC? Or would it just be A, C? That'd be a question I would have for this problem. I guess another sort of like question of the input. So what do we know about the input? Based on the example, it's all lowercase letters, so I guess we can assume that input is a string, and it should probably be between like length 1 and something very large, maybe just like infinity length. And I guess given that, it should be pretty efficient. But I'm not sure how we would do that. I mean, I think recursion is the right approach. But still, I think a while loop is also fine. Yeah, I think that feels a little bit easier too. Okay, so basically we're just like, as we, with while though, likely. Okay, so if we're to just like try to summarize this problem, it seems like we just want to process some string, and the processing, being the replacement or the substitution of duplicate letters. Yeah, until there is nothing, until there are no duplicates. Okay. So we need to process some string and basically until there are 0 duplicate characters. So I'm wondering, I'm thinking of another edge case here. In the example, in the explanation that they give, it's always just like a pair of values. So like A, there's 2 A's. So I think if we had like a situation where it's like A, C or something, I think that produces B, A, C, something like that. Dog's barking. One second. Calm down. Okay. So that basically means that we're going to be like consuming letters as we go. And really, I think it makes the most sense to represent this as like an object or something. So like, let's just say for this example, we would represent this as like A3, C1. Then I think we would just want to transform this object and then eventually represent it as a string again. So I guess for every element, I think we just want to reassign values. So like in this case, I think we want to check to see, okay, is value greater than 1? And if it is, then we would want to do something. And once we do that, we would have this new object. And then we would do that again. So basically, until everyone is less than 2, the value for each character is less than 2, we would want to keep doing some operation. So I think that is how I would approach this problem. And I'm sorry for the dog intermission. So I think we can confidently say that input is a string of length 1 or more, containing either upper or lower English characters. So that's how we're going to limit our input. So we're not going to have to worry about the wrong data type or non-English letters that are like symbols or something. We're not going to worry about that. So yeah, I think that makes sense. I've kind of already summarized this, and then so I guess we just want to return some string which has 0 duplicate characters. Okay, so as I envision this in my head, it seems as though we would want to, I think I'm going to standardize case. Okay, so standardize case of input string. And I think if there's like a situation where like guard for input length of 1, in that case we could just return early. Okay, and let's grab this test case as well and just add that to our test cases. Okay, so this should just produce CZ. Okay, so yeah, I have an algorithm in mind, or at least an approach. I'm going to try to flesh that out with my steps though. So let's transition to this view. Okay, so we're standardized in case of the input string, and then from there, I guess another question I would actually I think I'm jumping a little early into problem solving. I think a question that we could ask is like, will there ever be spaces? And I think given the examples, it's likely that there wouldn't be spaces because they specify that the input is just letters. So yeah, I think that's fair to say. Okay, so we want to standardize the case of the input string. And then from there, we want to essentially loop through, make a certain number of operations that once we have done so, processes out the duplicate values. And we were thinking of using an object for that. So I think first things first is we want to convert input string into an object that tallies the various characters occurrences. Okay, so it would look something like this. And basically we want to process, so I guess while our string is object, we'll do letter tally object contains values, or I guess it contains a key with a value greater than 1. We want to do the following. Okay, and so we're going to be mutating this object as we go. And so basically for all of those which are, okay, so there's a situation where, like, let's say we're dealing with like a string like A, C. And so this would look like 2 and 1. This could be 0. So I'm thinking maybe if it is equal to 2, we would just want to delete that entry from the object. I think that makes sense. So in this case, we would just delete it upon some iteration of this loop, and then it would just be B1, unless there is a B there. So let's say, for example, it was A, B, C. So initially our tally object would look like this. So as we enter our loop, we're checking to see if there is any key with a value greater than 1, and there is. It's A. So then we would want to check its value. It's 2. So we would delete that key value pair and create B1, or B with the value of 1. And it should have been like this initially. So if we're just following through here, it's A2. So then we encounter that 2, and so we would delete that entry and then increment the value of that letter if it exists, and if it doesn't exist, we'd create it. Okay, so then that would make sense. Then we would do the same thing here, where we would check, okay, what's the value? It's 2. Okay, this seems a little more complicated than I actually originally thought. So then this would be replaced, and then we would check to see if there's a C, and there is. So we'd increment that. So then really this just eventually just becomes D1, this string here. Okay. So I think the approach that I was thinking of makes sense, but I think we're gonna have to split it up into some more, with some more detail. So yeah. So I think we just want to make one operation at a time. Yeah. Okay. Which I think that still works. So if there is some entry or some key that has a value greater than 1, we want to decrement that key's value by 2 and get the next letter in the alphabet. Once we have that letter, so using this letter, check if letter tally has a key which matches the letter. Okay. And then if it does, if letter tally has that key, increment the value of that key by 1. If letter tally doesn't have that key, add key value pair to object to letter tally. Okay. So we would have done that. Then we would move to the next iteration. So we would just essentially keep doing that. And then I guess we at the very end, if any of them, so maybe we need another conditional here. So like if the actually no, I don't know if that actually I think this is fine. I guess I'm not gonna worry about deleting the letters that are no longer present because we can just deal with that after we've worked through all of the once we've determined that there are no keys whose value is greater than 1, then we can just filter the entries which have a value of 0. We can just get rid of those down the line. So filter letter tally entries. So filter out entries whose value is 0. Okay. And then we just want to reconstruct string based on the values or the keys, the remaining keys in letter tally. And at this point, it might be an array of arrays. Okay. Turn this string. Okay. So let's walk through an example. Let's just use this example. So, and just for our purposes, we're going to look at it like that. Okay, so regarding for input length of 0, so that's not the case with this particular example. We're going to standardize the case. So now it's going to look like ZZZAB. Okay, so that's what it looks like here. Oops. Okay, so we'd have that, and then we want to convert input string into an object that tallies the various character occurrences. So here we're going to use reduce. And so it's just going to look like, oops, let's put that here. It's just going to look like Z is 3, and then A 1, and B is also 1. Okay, and we've actually forgotten to go into detail about how we're actually getting the next character. So we have to check to see. So basically for situations where Z, we need to decrement. So actually we can just write that straight into this situation. So decrement that key's value by 2 and get the next letter in the alphabet if current letter whose value is greater than 1 is Z, then we can maybe just what's the value? So you use character codes. Yeah, so I think we're gonna have to use character codes here. So then we just take character code. I think it's character code at, and then like whatever the index is. Um, get that and then subtract 26. So that should bring us to A. Okay. And then from there we would get the from character code. I'm kind of not super clear on the syntax here, but I think that's a valid approach to deal with Z and to deal with all of the characters really. So this is for the purposes of getting the next letter. This is our general thought process. So for this one, we're checking, okay, there is some key whose value is greater than 1 in letter tally. So we're going to identify that letter. It's Z. Call character code at index 0 on Z, and that's going to produce the ASCII for Z, and then we're going to essentially get the next letter, and using that letter, once we've also decremented the key's value, so now Z would be 1, we would then check to see if letter tally has that key, and it does. So then we just want to increment the value by 1. So we do that. And then if letter tally doesn't have that key, so this is not the case because it did have an A already initially. So then we move to the next iteration of our while loop, and object does contain a value greater than 1, and in this case it's for key A. So we decrement the value by 2. So now A is 0. We get the next letter in the alphabet, which is B. So again, we're using this situation, and here we're not actually subtracting 26. That's only for Z, but it's the same approach. So we get that, and then we check to see if it matches a key in our object, and it does. So then we increment, and then we iterate. So now we're checking again, and we find, oh, here's B. It has a value of 2. So we once again do the same thing, and so then B becomes 0, and we create a new key on the object, or a new property on the object, C. And then from there, we're done, because none of the values have none of the keys have values which are greater than 1. Okay. Okay. So then from there, we would just filter out the A and the B, and I'm not going to do this because that's fairly straightforward. And we just want to reconstruct with the keys, so we could just do object keys, then the object name, and then just join together. Because they say that it doesn't matter what order they are in. Order does not matter. Okay, so I think at this point I'm just going to get into the coding portion. And yeah, we'll go from there. Let me just get some space. Okay. So let's look at our algorithm. We'll delete this. Okay, so I want to guard for input length 1 and return early. So if, what's it called? String, we'll call it input. So if input length is equal to 1, we can just return input. Okay. And then we want to standardize the case. So let's do const standard standard case. This is just going to be input to upper or to lowercase case. Okay. So now we have it standardized. So now we want to create that object, and we were going to call that letter tally. So let's do that. Const letter tally, and we also need to convert this to an array. So split by empty space. Okay. Empty character. So now we are going to traverse this standard case array, and using reduce, we're going to produce an object. Okay. So first things first, we need to check to see if, so if accumulator current, if that letter exists in our object, then we would simply want to increment the value of that key, of the current key. So current or accumulator current plus plus. Otherwise, we want to initialize that, or we want to add that property onto the object. So accumulator current is equal to 1. Then we just want to make sure to return accumulator so that it actually accumulates. So we have our letter tally, and now we want to start looping through the elements with a while loop. So I think, so I guess while some value in the object has, how do we do this with an object? It's not iterable. That's a good question. How do we do that? So maybe we can write a helper function maybe. So like maybe while has key or has duplicate has greater than 1 val. Then we can pass in the object itself, so letter tally. Okay. We want to do the following. So while this, so this is going to be a predicate function. So we'll just write that now. Okay. Where do we want to write it? We can just write it below. Yeah, that's fine. Just create some more space. So let's write that here. Function has greater than 1 val. Really great naming convention. This will just be letter tally. Okay. So basically, I guess we could convert it to an array of arrays, so the entries, or we could just use like for in, I think. So for const key in letter tally. Just do something like this, and then it would just be we can use some sort of toggle. So like let greater than 1 equal false. So then if, actually it should be, do we want, because we want this to eventually return, so actually I think it should, its initial value should be true. So, or maybe none greater than 1. Okay, none greater than 1 is true. So then if letter tally key is greater than 1, then we want to return, or we want to set is true to false and break out of our loop. And then we would want to return is true. So that should work, I believe, because we're going to be iterating through the keys. Letter tally. Yeah. Okay. So if that letter tally, if it's greater than 0, then greater than 1, then we want to break and return the value. So in this case, it would be false. So then while none greater than, so let's just think of an example here. We're to like look at, shouldn't have deleted that object. guess if we just had like an object that looked like this, A2, B1, we would be checking to see, we would be checking all the keys to see if their value is greater than 1. So if it is, then we would want to, so this actually should be false, and this should be true. So then, so this actually should be has greater than 1. So sorry for my naming today. Has greater than 1, passing in letter tally. So then if it finds one that does have greater than 1, then we would want to set it to true and then break out of the loop and then just return this. So for this one, it would return true if that was the current state of letter tally. Okay, so that is dealt with. So now let's get back to our core function. Essentially, we want to decrement the key's value by 2 and get the next letter in the alphabet. So, but how are we actually getting the key, which matches? Well, how are we getting the actual key, huh? Maybe we want to do result, and then result. So then if okay, so I'm wondering how we would do this. So I guess we would want to set result equal to the specific key which triggered that, and then break and then return that key, because the key would be the letter that we want. So we'd set if how do we do this? I guess we would just we have the key at this point, so I guess we need to store that in a variable. Be like let key, and then we would set here, so key is equal to that. And so then if it's null, or if it just returns false, okay. So this is super janky, but I think it should work. So then if key, or I guess if it is going to iterate, so if this expression evaluates truthy, that means that we would have returned a key, so a string, so that would make it truthy. Then we would want to decrement the key's value by 2 in the object. So whereas our object, it's letter tally, key minus minus. So it just decremented by 2 actually. So minus equals 2. Okay, so we're decrementing it by 2. Then we need to get the next letter in the alphabet. So we'll just call this next letter. Actually, let's leave it at next. And this is going to be, so I guess if, yeah, so do, we do something like if, or yeah, const next is equal to if key is equal to z. If that's true, then we would want to deal with the z. So we would get key character code at 0. We get that, and then minus 26, and then this whole thing would be string character code from that number. I'm not even sure if this is a function. Otherwise, we would just get, we do the same thing, but without subtracting 26. Just add 1. Okay. Theoretically, that works. So see what our next step is. Using this letter, check to see if letter tally has that key which matches the letter. Okay, so if letter tally next, then we want to increment the value of that key by 1. So letter tally next plus plus. Otherwise, letter tally next is equal to 1. So creating the property on the object. Okay. So now let's just, I haven't run my code at all. So at this point, let's check to see what we're actually, where we're actually at here. Okay, let's just take a run. Character code from, yeah, that's not a function. That's what I was concerned by. Is it from? I have to look it up. Character from character code. Okay, I just had it flipped around the words. Okay, so where is that? From character code. Okay, so we're getting A, P, C. And what is the, let's log the actual input. Just to see what is being passed. Okay, so given A, B, B, A, we're getting A, it's supposed to be, this should be, there should be at least one A, right? So this would be B, and then, so it should be AC, and it is. Okay, so that works for that one. This one's supposed to be, I think it should just be a C. Oh, but what is that? That is very strange. Where's he getting that? Huh. I guess you, but this is, where is that coming from? That's so bizarre. It's like a tick mark. And given nothing, we're expecting a string. Okay, so 0 length. Okay, well, I'm gonna operate on the assumption that my solution is working, generally speaking. So we're just gonna continue. So we're at this point where we have letter tally and we're done. This is no longer true. So let's take a look at our algorithm. We're supposed to filter letter tally entries whose value is 1 or whose value is 0. So let's do that. So we'll just call this array of entries, array of valid entries. Oh wait, valid entries, and that's just going to be object entries from letter tally. Okay, and let's just return that to ensure that everything is working as intended. Okay, it's an array of arrays. Great. So now we want to filter that based on some condition. So filter, this would be something, and then count. Okay, and then we want only those whose count is greater than 0. So really all of them that just have 1. So we're expecting to no longer see the B0 or the Z0 in that test case. And we don't. Great. So now let's just get back to, oops, this is the tests. Yeah, we're up here. So now we really just want, so this will just be non-zero letters or entries. Okay. And now we really just want the, I guess we could map this. Yeah, we could just do return non-zero entries, map. These are arrays, so it's going to be like just letter, so character, and then we don't care about the secondary element in the subarray. And then we really just want the character, and then we want to join it. So, okay. So we're passing this one. I don't know where that's coming from. That's really bizarre. I think there must be something wrong with maybe I'm subtracting too much. Maybe it's supposed to be 25. I think that's where we're going wrong. Minus 25. That's the only way that backtick mark would actually show up. Okay, great. So passing those test cases. We're passing all of them. Okay, great. Sorry for a super sloppy presentation today. I was a little distracted, and it's kind of a challenging problem. But yeah, thanks for sticking with me if you did. I'm not sure if I'm going to post this or not, but yeah, this was fun. Peace.